Hi, everyone. Thank you for being there. Well, the first fact we are going to talk about is how GPU consumption, power consumption, sorry, is growing so much. Today, Damien, this morning, announced that we have B300 available at Scaleway. What does that mean? That means that we have GPUs consuming 1.5 kilowatts available in our data centers. And this is just right now. But next year, we assume and we know that the GPUs will consume 2.5 kilowatts. Consuming so much gives us real need to understand how we are going to cool all these GPUs, how we are going to be able to manage the servers, the data centers, to be able to have the best powerful performance for AI, but also to be able to cool it. So we have a great panel today, very special people you are not always used to see, and I'm very happy of this. So if you may, could you please present yourself and your companies, and sometimes a bit more, explaining why your company is here today.
So good afternoon, everybody. So thanks for the introduction, Alban. So Christophe Lacroix, I'm the Chief Innovation and Sustainability Officer of the Motul Group. So for those of you who may not be aware of who is Motul, so Motul is has a long heritage. It's a 170 years old company, and we are operating in more than 160 countries in the world. And what we do, we design, manufacture lubricants mostly for automotive industry, motorcycle, and we do also a lot of products, coolants for automotive. And obviously, as you know, there is an energy transition. So we recognize this energy transition and we want to be participating to that transition. So what we have a lot of developments with regard to new powertrains, new fuels, and since we started that journey, we also started cooling batteries. By doing so, we developed dielectric fluids for cooling batteries. And if you're not familiar with batteries, in batteries you've got a battery management system. So we started embedding those systems into fluids, and it works very well. So it's very efficient. So we transition from battery management system to servers and develop products. So our innovation today is really geared towards bringing in new powertrains or in new technical fields products with sustainable credentials, because since we are a 170 years old company, we could have done the same things, but we decided to move really with a focus on renewability and sustainability. So we've been developing those dielectric fluids with sustainable credentials, and they can be used in immersion. We did also the same with direct-to-chip and developed product bio-based in order to cool down the chip. So we transition actually from automotive, and we expect that we will be able to participate and bring all of our knowledge, all of our know-how and dedication, because we are a team, that is also strongly involved in racing, and in racing it's all about passion, like the people that you can meet here in those events. It's all about speed, and we talk about speed here every second. So we really hope that we can also put our input and our passion into this business.
Thank you.
Thank you, Alban. So, Frédéric Petit, I'm Research and Innovation Director in Valeo. I think that you may all know Valeo, and you may wonder why we are entering into the data center business. So Valeo is one of the biggest technological player and partner of the automotive industry. We have a worldwide presence. We are leader in electrification of cars, in interior experience. We are working on lighting and also all what is related to automated driving and ADAS. In Valeo, we have a specific activity which we name Beyond Automotive. So we are looking at all what we can do using our core competencies, our product in some new fields. So a few years back, we decided to enter, for example, in two-wheelers, in e-bike, in charging stations. So we are developing this kind of activities. And we also noticed that we have a very good matching with data center cooling based on our experience in a cooling system. So basically, when you think about that, you look at the battery, very similar story than Christophe. We are leader in cooling of battery. We are supplying a cooling system to OEM like Tesla, BYD, and others. And we have already followed the development of the cooling of batteries, starting from air cooling to liquid cooling, immersion cooling. We are also very specialized in two-phase direct-to-chip cooling. So this is one of the reasons why we entered into this data center business with some partners. I can name a few of them. So we have developed some solution for immersion with 2CRSI. We have developed some air cooling and the rear door solutions with OVH Cloud. We are developing solution for direct-to-chip two-phase cooling as well with companies like Zutacor and Kalios. These are the things that we are doing today, and we can discuss more about that during the questions.
Bonjour, hello everybody. So my name is Bruno Lecointe. I'm used to know as the orange glasses. I'm working for Eviden, that is part of the Atos group, till Q1 26. Why I'm saying that is that most of the French people and some European people knows that we were Bull. Bull was a company created in 1931, and the French state decided to buy the activity, so which means that in Q1 26, we will move to a new company that the name will be provided in January. For the color, we are still trying to understand which one we are going to do. Our history is to do advanced computing and AI for many, many, many years. And we have 3,000 people dedicated to do that. We will discuss about the direct liquid cooling, but we are used to work with different partners. We work with NVIDIA, we work with AMD, we work with Intel, we work with Cypel. We start to integrate the new AI inference chips made by different European startups. So this is something that we do for many, many years. And direct liquid cooling that now is a hot topic in the AI is something that is not a hot topic for the HPC people. And we do that from 2012, and we will discuss about that, but happy to be there with you.
Hello. Hello everyone. I'm Albert Hai. I'm from Giga Computing, a company of Gigabyte Group. And I come from Giga Computing infrastructure team. We provide AI and HPC solution to our customers. And we design and deliver like direct liquid to chip, immersion cooling solutions, and AI integrated rack. For example, like NVIDIA HGX racks and GB200, 300, NVL4, as well as like AMD Instinct GPU families. Our customer is worldwide. For example, like Eviden is one of our biggest customer, and we provide those solutions, and our main goal is to fulfill our customers' like performance and sustainability requirement. It's great to be here and let us see how we shape the next-gen AI hardware infrastructure. Thank you.
Thank you to all of you. So I would like to begin with Eviden. The top 500 has been published recently, and you have two supercomputers which are in 4th and 10th position, which is quite amazing. It's talking about performance, it's talking about cooling. Can you tell us more about it and how you did this and the specificities of your design which enables this performance?
Yes, sure, my pleasure. So if you look to the top 500, is a ranking in the world that is classifying the biggest system in terms of flops, but does not speak about the efficiency of the systems. So we are number 4, so there is 3 American systems in front of us. It's a matter of budget, just to be clear. But it's true that we're number 4 and number 10. We have 58 systems inside the top 500. What we should look absolutely the Green 500, which is another international ranking. And there we have the full podium, number 1, number 2, number 3. By the way, with 2 French systems plus a German system. And these systems are showing that with our DLC solutions, the way we design from the data center to the use case, the systems, we can provide 5 to 8% better efficiency than the competition. And this is something that you need to understand, that this efficiency is much more important than the top 100 classification. It's like the cars. Most of the people in the past were buying the biggest car with the biggest engine and how many liters you can have in the engine. And in fact, today, everybody is looking to the how much kilometers you can do for 1 liter of fuel or electricity. So this is exactly where we aim to go. And we did that because we were integrating everything. 100% of what we did was always targeting to be efficient, more important than being big. And when you are just targeting that from the design of the hardware, from the design of the software, but also providing the teams to optimize the code of the users, helping them that the codes are not wasting times or energy. This is how we were number 1, number 2, and number 3 in the world for the Green 500. So this is something that we need to be very careful because there is a huge wall. Everybody speaks about AI. We see that we speak about megawatts. I will give you an example. The 4 biggest systems in the world, we are number 4, which is called Jupiter. It's a system that we sold 2 years ago in Germany. But if we look to the efficiency of this, the big system is number 1 worldwide because it provides 5 to 6 better flops, so the computation capacities per what they are using. So which is something very important because when you look to the size of those systems, which are 17, 20, or hundreds of megawatts, every percentage of efficiency that you can get from the direct liquid cooling and the system design, you will save a lot of money.
When we talk about percentage of efficiency, Albert, can you tell me us a bit more of what has done Giga Computing in terms of design? We'll talk of materials afterwards, but in terms of design for optimizing performance?
Okay. From my point of view, it's quite astonishing that maybe 3 years ago, the TDP of GPU car only got 700 watts only. And for the future, it's going to be like 2.0 kW. And basically, from the Giga Computing point of view, we redesign all the thermal design and air rack design because we need to have more like better thermal performance design. For example, let's start from the cold plate. We changed the material to 100% of copper because this material can have like a better thermal conductivity, and you can uniform the thermal to the dies. And furthermore, we have our new design and developing the cold plate. We design as like a micro loop design because you can have like a more good flow and keep the GPU junction under control. And furthermore, we also modify our chassis. One thing is that we optimize our internal manifold because that we also need to rethink how to minimize the pressure drop and to balance the APCs of like HGX GPU or like NVL 22 GPU. And another thing we need to rethink is that the heat coverage. Our next gen design of the cold plate is not only cover the CPU, GPU, memory, we will also cover the drives. We will cover the networking card for InfiniBand and the Ethernet networking card, as well as like the capacitor on the motherboard itself. It's for the server level. However, for the AI solutions, we also need to think about the AI rack. So we have like optimized the power distribution, the coolant manifold, and as well as like a cable routing. And we also need to think, not the thermal itself, we need to think about the safety, logistic, and the maintenance. Yeah.
Thank you very much. In terms of design, for Module Valeo, we talked a lot before this panel about the different immersion or different cooling systems, and what you can see in terms of design on this. Could you tell us what is your vision, and then we will talk about the material and the fluids, on the best solutions?
If I can start, you allow me to start. So, because I think we share the same point of view. So in terms of cooling today, as mentioned by Eviden, AI now has really embraced direct-to-chip cooling, and therefore this is why we have developed this bioglycol for that purpose. And mostly you've got a definition where you've got either immersion or direct-to-chip. This is the biggest category, and then you've got single phase or two phases as far as the products, the fluids are concerned. At Motul, we decided, because we wanted to be bio-oriented and with bio-credentials, we've been focusing on single-phase fluid. So far, we are not able, and we don't know how to make two-phases biofluids. But we've been focusing on single-phase fluids in order to be able to bring direct-to-chip cooling or immersion. And all of our solutions are geared towards those sustainability credentials.
Okay, thank you. Yes, in terms of solution, we can see a set of different solutions today, depending on the type of rack you have. If you start from the first one for the cloud and going to AI, with, let's say, less than 20 kilowatt, air cooling is still there. You can have the introduction of the rear door, which is allowing you to go up to, I would say, 50, 60 kilowatt per rack. And then after, with the last generation of GPUs, you are almost compelled to go to liquid cooling. As you said, we have the single-phase liquid cooling, which is, I would say, for the last generation of GPUs, almost mandatory today. And then after, you have the two-phase. At Valeo, we're working on the two-phase. This is one of the things that we used to do based on our past experience on climate control, climate system, I would say, air conditioning. So this is something that we master very well. And we have started to produce a CDU in two-phase and also manifold and all the solutions for two-phase direct-to-chip cooling. This is quite efficient. I mean, something for high-performance computing, which is working very well. I would say when you are starting to reach 1,500, 2,000 watt per GPU, something that is giving very good results. The heat transfer coefficient is 10 times bigger than single phase, sorry. But there are the problem that you highlighted about the type of fluid that you are using and the PFAS which is inside. So we are using very low PFAS fluid, and we are waiting and working with people like Motul and others to look at what could be the next generation of fluid for two-phase direct-to-chip. These are the solutions. And of course, immersion. Immersion is quite good. We are also working on immersion. We have one development which is ongoing, as I said. And we believe that for the edge computing, it's quite efficient. It's both efficient. You can have a good heat reuse with this kind because you are capturing a lot of the heat. And also, on what we are proposing, it's a system which is fully autonomous. And this is one of the advantage of the immersion cooling is that you are protecting the server and you can put it in very harsh environment, and it's quite good for this kind of application. So this is, I would say, not one single solution, but a set of solutions depending on the type of application that you have.
I thought you wanted to say something, so I was just waiting for you if you wanted to say something.
Merci, Alban. Now, yes, this is interesting because if you speak to all of us, you will see that we speak about three types of, let's say, cooling systems. The first one is the immersion. From our side, we don't do that, but it's a way to do that, and it's not totally new. In 2000 and before, Cray, Fujitsu, and NEC were already doing immersion for the electronics. So it's something, it's a kind of loop. Today, we do that, it could be better in terms of efficiency in the cooling. But if you look to the direct-to-chip cooling, there is two types of technologies. There is systems, and you were describing that very well with the rear doors that you can do, is that you will cool the CPU, the GPU. Where it's very different, and this is where we think there is two companies in the world doing that. The first one and the second ones are HP and Eviden, is that you cool 100% of every electronical components, mean the compute nodes completely with cold plates, as you were speaking, but also the network, also the management, including the power supplies are water cooled. And the fact that when you design that taking into account that the water temperature that you need to put inside the compute is 45 degrees Celsius, which is a big advantage. If you start to use a system with hot waters, as we do, you need less cooling to run the system. So this is where we need to really understand that there is different ways to do, there is different market, different needs, different budgets, which is another story also. But this is something very much important, that this direct liquid cooling depends how much you integrate in. The liquids, and this is where Motul is working on it, are coming with new technologies, I mean, better fluids. There is an improvement, but this is something, it's clearly the design that will make the change.
Thank you. On Scaleway point of view, there is something about what you are telling us about is maintenance, because this is this great design that we can implement in our data centers, and then there is us and our teams. And the maintenance at scale of this type of technologies are not, I don't know if it's complex, but anyways, a new way of working, of course, and new way of seeing all the productivity, the way we deal with the machines and with the way that we maintain them. How do you manage this with your clients, to this conversion from air cooling to liquid cooling and to immersion? Who wants? I was more on you. You can, yeah.
No, you are
yes,
more on me. So, for the maintenance, there is two things that you need to take into account. First of all, the experience. I'm not kidding, is that a lot of people start to do direct liquid cooling now. And we see a lot of people having a lot of issues. When we started in 2012, we were facing many leakage, many issues. But the experience in the way you design a system, that you make sure that the pipes are doing the right curves, they're doing the right size, and you control all the fluids going inside on the design. Albert was speaking about moving from aluminum to copper was also a way to improve the dissipation. This is where you need to be very careful, because this maintenance is based on the experience, but also the fact for us, for example, that we integrate in the design of our component what we call the aging. All the materials are by design, by nature, losing their capacities. So you have a degradation about the component for the liquids, but also for the materials. So when we design something, this is why sometimes it's a little bit more expensive than the air-cooled system or basic DLC systems. We integrate that the system is going down in terms of performance. When you speak about 2,500 watts for a GPU, we are doing today proposal to some customers that where we will reach 4,000 watts per chip. It's huge. So this is where the system. So for that, you need to develop software sensors that are able to do predictive maintenance, that are going to do a very tightly monitoring of the system. It's not just hardware, by the way. There is a lot of software that need to be provided by that. So if you combine right design, the software to monitorize, and the experience to do the installations, the maintenance should be okay.
Everyone agrees?
I agree. I agree.
Yeah. You think that everything is going to be okay?
Yeah, I agree even more that we are also developing predictive maintenance using AI, because it's quite important. Something that, well, in the automotive, something that we are used to see. We are detecting, anticipating the failures, and going to some fail-safe mode. So this kind of monitoring is something which is quite important. Yes, I agree.
I can also share like experience in our project. Just like you said, like monitoring is very, very important, especially like how to detect the leakage of water into the coolant. So our experience, we not only depends on the software itself, we also install around tens of sensor detector, dielectric detector to avoid like leakage of water inside the coolant itself, especially like carbon hydro mineral oil or fluorine oil, something like that. Yeah, thank you.
And just to complete, if you speak about maintenance, typically, you know, maintenance for you is downtime, so you don't want downtime. And if you speak about immersion, one of the usual drawbacks that people claim about immersion is that if you lift up a rack, you need to wait that the oily liquids may dip. So at Motul, we recognize that, and we also have developed cleaning fluids where you can move the server from the dielectric fluids to one cleaning fluid in order to remove quickly the thin film and be able to do the proper maintenance.
Maybe one thing I wanted to add, we are talking about 4,000 watt, which is huge. We are talking about direct-to-chip, liquid cooling. The speed, the flow rate is getting higher and higher, and we have also some issue with potential issue, but not so potential. We can see that we have some erosion occurring in the cold plates, so we have to be very careful about that. That's also why we are focusing for higher TDP to two-phase. But yes,
that's a good comment, because when we started with the XH3000, that was a system sold 2 years ago. The system was doing 167 kilowatts per rack, 42 euro racks, more or less. We started with a new system in November. We launched the XH3500. It's doing close to 300 kilowatts. And when you look to the design of that, there is no big changes, better power supply. But the fact that we were carefully restudying the pipes, the connection, the curves of the fluids, and be very careful with that, we were able to increase the efficiency of the cooling by 30%. So this is true that we need to, it's something that is very sensitive to make the flows of the liquids going easily to your chips.
We only have 3 minutes, so I'm just thinking which question I want to ask at the end. Maybe because we are talking a lot about a lot of watts consumed everywhere and how we are going to consume even more. Maybe, Albert, you were talking to us about what you have done to improve and to reuse this heat that has been developed.
So sorry, so you want to do it, I do it, I don't care. But,
so
yeah, we have examples of that, just to be clear.
Yeah,
so
of course, everyone has examples. Okay. If you want to have some, Albert, I know Albert had one. If you want to have tell those two, you can.
Okay, so I start. So reusing the heat is not new, just to be clear. If you look, when I start to be old, I'm 54 years old. When I started in 2000, several people were speaking about free cooling, reusing the heat at that time. And there is people like CSC in Switzerland, which is in Lugano. They were using the water from the lakes. They were going up. They were heating the water because they were using that. They were going back to a swimming pool, and they were helping the swimming pool to have hot water. One of the best examples we can give you today is what Idris, which is based in France, it's a Gen-C Idris CNRS reference. They are today reusing the heat that we produce with our system to make the more than 1,500, if I do remember well, families heat in the houses and the flats. So there is a way to do that. It's something very much important. What we used to say for us that reusage of the heat, it's something important. But first of all, start to do not produce much heat that you need. It's essential. So the best way to do that is to be very careful between the design, the hardware you buy, the software you put on it, and the codes that you are using. If you optimize the application, you can save a huge amount of watts. And it's really important. So again, if you need help for that, speak to people that are used to do systems end-to-end, from the electricity power to the use cases that you need to have on it.
For our experience, we cooperated with like a semiconductor manufacturer in Taiwan. Actually, we have both like OCP direct liquid cooling AI rack, as well as like immersion cooling GPU PCIe solutions. But these two solutions are used in a building. They call it as a lab or fab. But the cool water comes from the cooling tower. Maybe the temperature of the water comes from 12 degrees Celsius. However, it goes to their lab, and the water will like heat up to like 4 to 6 degrees Celsius. And the water once become 18 degrees Celsius, it comes to our IT equipment. and it generates a lot of heat. And the facility water goes down to the third floor. The third floor, another lab from some manufacturer procedures, and it becomes around 6 degrees Celsius. However, the last stop, the last station, maybe in the second floor, their manufacturer precision cool down the water to around 15 degrees Celsius and go back to the water chiller. It becomes a circle. It becomes like a building water facility closed loop. That's another thinking about how they use the reuse the heat and to meet their enterprise ESG target. It's the example we met in Taiwan. Yeah, thank you.
Thank you very much. Thank you very much to everyone. We have to stop because it's now time. They're going to be mad at me if we don't stop, but we can continue to discuss afterwards. Thank you very much to everyone for being there. I hope it was interesting for you as it was for me.